Hello, dear students. This is Professor John Forsyth, and today we're going to go over Python Crash Course Chapter 10 and take some of the key principles that are taught in that chapter and demonstrate those. So, as I like to do, let's just leave some comments of a summary of what I want to go over today. So, first, I'd like to talk about what paths are and reading and writing files with text. So we'll go over that first, and maybe we'll talk about a little bit, very briefly, about encoding, and then let's talk about some exceptions, and finally the fourth thing, kind of conflated here, but we'll talk about reading and writing data in Json format. We'll talk about a little bit what Json is. Okay, so, and apologize for my voice, a little bit hoarse. I think I've been talking too much. But in any case, paths are actually kind of an intuitive name once you know what they are. So we save files in a location on our computer in like a folder, or sometimes we call a folder a directory. Those are synonymous. And its location is also its path. So for example, if I hover my cursor over this file called main.py, my Python file here, it shows me C:\/ users, John 4S, and Python projects, BYU Ling 360, exercises main. So if you follow that from the beginning to the end, those are the folders you have to follow to get, or the path you have to follow to get to this file, okay? And there's a couple ways we can write paths. We usually use, so Windows uses backslashes, and I'm on Windows, so when I hover over this, you can see those backslashes. Backslashes lean to the left. But when we write forward slashes, because most other computer systems use forward slashes. Linux, Mac, they all use /, and Python uses forward slashes when we are writing our own paths. Okay, so there's a library called the path library, or pathlib, and we can use that to read and write files. So one way we can do that is we say from pathlib import path. So if you remember from last chapter, classes start with a capital P when you create a class. So technically this is a class. I won't go into that here. Consult chapter 9 if you want to understand those. So, but we have this path tool, and we can create a path from it. And so I just want to read some text, and I've been using the same file that the book uses. If I click this folder here, I can see that inside my exercises folder, I have main.py, okay? And that just so happens that I have my Adventures of Alice and Wonderland in the same directory. So the path, or the location, relative to my script, and I need to do it relative to the file that I'm writing, the code file, is actually in the same directory, so I don't have to do any slashes. I just give the name of the file. So that's convenient. So if I do that, that's going to give me back what's called a path object. So I'm just going to call it input path. Okay, so that's the path to my file. Same location, so the name of the file is the path. Just one other thing I could do that's also equivalent is a / means current directory. Sometimes that can come in handy, but a single dot means my current location / and then in this current location, this file. So this is also going to work, okay? And I'll just leave it like that, but just a couple options there. So now I can read the text from this using the read text method, and it'll do autocomplete there for me. So now I have my text, and I could call it whatever I want. I'm going to call it my text, and then we'll just print my text, okay? Just to show that we do have that. And this is a string, so, and this is a large bit of text, so I don't want to print all of it because it'll just kind of look ugly. So let's just print the first 50 characters. Okay, so I'm taking a slice of this text from 0 to 50. I could also put the 0, but that's implied if I leave it off. So now if I do that, I get an error. Char map code I cannot decode. Okay, so this is great. I get this error, and the problem is this. I need to specify the encoding of this file. Sometimes it'll work without doing so, but I need to specify that it is encoded in UTF encoding. I'll talk about, you can ask me directly, or we'll talk about encodings in class sometime. So okay, so now we have the first 50 characters. So we have some space characters, new lines, down the route hole, else was begin, and it cuts right there. Okay, so that's how we can read a file. We could also write a file in a very similar way. And I'm going to show a variation on paths. So let's just start fresh here. So delete everything. So let's have some output text. And I'm not going to write anything intelligible, just a bunch of scribbles. Okay, just need to get some text. Okay, and then I'm going to create a path of where I want to output this. But there's another, so inside quotes, if I want to go up one directory, you already saw a single dot, which is current directory or current folder. If I want to go up one folder, I can do ... and then a slash. So I'm working this relative to where this code is being saved in this main file. I'm inside the exercises. Okay, so if I want to put it up one directory, it's going to be stored inside BYU Ling 360. Okay, so, and I pick the name of the file. So ... go up one directory. That's the path that I'm following. And I'm just going to say output .txt, just something generic. Okay, so that's my output file. And I need to save that. So output, save this path object, output path inside this variable. And now I can write the text. Output path.write text. And I need either literal text or a variable that has text in it. And I do have a variable above that I created called output text. So now if I run this program, I should have some output. So notice I've got this output text, and it's not inside the same location as my main program, main.py. It is up one folder because I did ... So it's inside output.txt. I could have gone to a different location. I even could have, if I delete this file just to show that this works, I could say, okay, starting from my current directory, then go up one directory and put it in output.txt. This is the same as if I would have left this off, but sometimes that could be, if you're familiar with reading paths or coding for other programmers, this can be useful, or maybe in some cases necessary, to specify I'm starting from the current directory. So again, this is the same as I did before. If I play that, my output.txt appears again in the same location inside BYU Ling 360 folder. Okay, so let's delete that just to keep it clean, and we'll go on to the next part. Hopefully you've watched some previous videos and you know my principle of pausing anytime you want to test these, because I do go fast, so it's probably necessary to pause rather than trying to keep up with my typing. Also, take note that I've gone through this before in preparation, even as an experienced programmer. You know, I don't memorize every single thing that every language has. I've learned multiple languages, and so I have to go back and review to prepare for this video. So I'm primed to do things a little bit better than I would have. I just don't want you to take the time to see all my mistakes, but you're going to make mistakes. That's part of the learning process, or the reminding process, which I go through myself. Okay, so let's look at, we looked at encoding. Now let's look at some exceptions. Okay, so exceptions are, the chapter calls them objects that basically help handle errors when your program has problems. So let's generate a couple problems. One problem we could have, if we go import pathlib, or rather from pathlib, import path. Okay, we could have a file that does not exist. So if we have non-exist, I'll just keep it short. Okay, so path blah.txt, this file doesn't exist, I just made up that name. And if we try to read some text from it, non-exist.readText, call the readText method, I'm going to get an exception. So if I play that, and my exception is file not found error. Okay, so in some cases we may want to handle this exception rather than having our program crash and frustrating the user. Maybe we want to handle this gracefully and just print a nice message and continue our program. For example, if this were going through a list of files and reading text from each of the files in that list, maybe potentially one doesn't exist, so that's a good case where we might want to handle an exception. But I'm just doing one example, one single file, just to show how how you do this. So you're going to do what's called a try block, and what you want to put inside the try block is the code that could possibly fail. So right now this is where our code is failing, so this read text, when the file doesn't exist, could fail, and in our case it will fail because we already saw that. And if it fails, you want to have the except keyword here kind of catch, as it were. Some programs actually use some programming languages use the word catch. So we know specifically what type of file we want to catch, or what type of error, or what type of exception. And I'm conflating terms, but programmers do that a lot, so it's good to get used to the lingo. So now this basically will, instead of throwing this red ugly error message, we can print our own custom error message and the program doesn't crash. Here's my friendly message, and my program continues, and I can prove that by printing this is the end of the program, which would not have printed previously if I had not handled with try except this exception. So let's play that. This file does not exist, and this is the end of my program. I could have done an F string and the name of the file inserted in here. That would have been even more helpful, but hopefully you catch the principle of exceptions, how the basics of how those are done. So let's just do one other quick exception. We could have division by 0, so let's say input give me a number, and we'll put it in our number variable. I'm trying to type and think at the same time, or talk and type. So we need to change that to an integer because input comes in as a string. So we'll convert this number to an integer so we can use it in division. And now this number variable is, instead of holding a string, it holds a number. And then we could try to divide 5 or 6 by our number and result, and print the result. Okay, so we're gonna, if we input a 0, this is gonna give us an exception. So let's play it. Give me a number. I'm gonna put 0. Let's do this again. I've got, let's see, I think, okay, let's try this again. So play that, give me a number. I think I know what's going on. Okay, 0 division error. Okay, division by 0. We can't divide by 0. It's undefined in mathematics, so as well as in Python. So this is another potential place where we could do an exception or a try around the code that possibly could fail. So indent that and print our result. We'll put that also inside there, and then except. So we could catch any type of exception. We could do a 0 division by 0 division error explicitly, but if we want to just capture any possible type of exception, we could just do except, and that'll catch all exceptions. Let's play that. Give me a number. can't divide by 0. Great. And our program exited with code 0, which means no errors were encountered. So let's close that. Now let's go over the last principle that we want to teach in this short video. We want to look at reading and writing data in JSON format. Okay, so to do that, so JSON format comes from JavaScript. It's basically Python dictionaries, but JavaScript kind of beat us Python programmers to the writing data to files, I guess, terminology. And so JSON actually is short for JavaScript. That's the JS part. Object notation. It's basically just a way to write data, and essentially it's the same format as Python dictionaries, where you have a key and a value. It includes lists as well, but typically you'll see JSON stored like this. Or you could even have like a value could be like a list of something else, like a list of numbers. This is all basically JSON format. So Python, we call them dictionaries. JavaScript, they call them JavaScript objects, but they're essentially, like very similar. So there are some differences, but they're pretty similar. Okay, so let's say we build up our own dictionary. So we want to get maybe some numbers. So let's generate a list of numbers using range. And if we just give it 5, that'll give us 5 numbers, 0 to 4. But it gives us this range object. We want to convert that to a list. And let's get some letters as well. So we'll just do A, B, C, D, and E. Okay, so what I'm going to do is just create a dictionary that has these letters as the keys and 5 numbers, 0 through 4, as the values. So just to get a dictionary, that's all I'm doing here, rather than having to type it up. So we'll do a for loop, and this for loop is going to return 2 values, because I'm going to use something called the zip function built in, and I can zip 2 lists together with that. And I'm going to zip the numbers and letters. Let's put the letters first. So letters, or letter rather, because we're going to go over 1 letter and 1 number at a time in the result of our zip function. So sorry for that smart output there, or the hints. It covers up what I'm trying to do. Okay, so we're zipping the letters list and then the numbers list. Each letter is going to be the first thing, and it zips them in pairs. So like A is going to be matched with 0. We'll just print it so you can see. Yeah, let's print it first as an F string. So print our letter and print our number. So we'll play that. Okay, you can see how it zips those. But what I actually want to do is build up a dictionary. So let's call it my dictionary. It starts off empty, and then we're inside our loop. We will write to it, write a new key, which will be the letter, and the value of that key will be the number. And after that's done, we'll unindent and print the result of my dictionary. Okay. Trying to go fast because I want to keep this video down to 20 minutes, but there's our dictionary. Okay, so now if we import a library called JSON, that will allow us to convert data to JSON format, which allows us, it's a very common format for saving data in files. Okay, so we can save our dictionary as a JSON object, which is it's very similar to a dictionary, as I said, but there's some differences, and it allows us to share data with other programmers using other programming languages. Okay, so let's just call it data. And there's this, using JSON, we can use this function called dumps, and that just basically converts your dictionary to JSON data. In fact, let's call this JSON data. Okay, so and then we want to use our we want to write this to a file, so let's use our pathlib. From pathlib, import path, and just in the same directory we will have a file called JSON output. you typically have the prefix or the suffix .json for JSON files, so it's clear what type of data it has. And then we can write that JSON output dot write text and write out our JSON data. Okay. So we're going to go over a little over 20 minutes, but that's okay, not too much. So it wrote this output.json file. If we open it, you can see it uses JSON. One slight difference: it uses double quotes. Python allows single or double quotes around strings, but JSON uses double quotes around the keys of essentially what's synonymous with your Python dictionary. Very, very similar. So this is great, but we can also read our data back in. So let's just continue the code here. And well, we'll get rid of this because we already did this. So we have our code. But if this was, yeah, we've already done all this work. So let's just delete this code. But we still need these two libraries because now we're going to be reading. So the input is going to be, I'm going to do this all in one line to show how you can chain things together. So we have the name of our file is output.json and .read text. Rather than storing that in a separate path object variable, I'm just straight doing path and read the text directly. So that can save on some code if you're familiar with how this path object works. So now I have my text inside input, and it's a JSON object, so we might think, oh well, I have a key inside there that's A. So let's print that key and see what error it gives us. Okay, so it gives us some type error because this is a string, it's not a dictionary. Sure, it's a string that looks like a dictionary, but we need to convert it to a dictionary. And the JSON library that we imported above on line 3 allows us to do that. So we could say my dictionary JSON.loads. So this will convert it. If it's properly formatted JSON as a string, this will convert it to a Python dictionary. So JSON.loads input. I just want to load the entire input. That wouldn't work anyways. We already got an error doing that. So now I can print whatever, the whole dictionary or whatever's stored in a particular key. So we could print what's stored at A. It's going to be 0, not super interesting. I'll also print the whole dictionary so you can see. And we'll wrap it up. So there you go. You were able to write the data out as a string, read it back in, convert it to a Python dictionary using JSON.loads. And now you can use it as a dictionary in your Python program. Thanks for watching. Hopefully this was helpful.